And we are recording. So welcome everybody. This is the AP Calculus Teacher Q&A with former chief reader, College Board table leader currently, College Board consultant, AP Calculus textbook author, or any other role that you can possibly imagine in the AP Calculus community. We are here with Steve Kokoska, and he has been so gracious to volunteer time tonight just to open it up for teachers to ask questions, participate, find out anything you can for this one last push before the AP exam on Tuesday, as well as not just for this year, but then things that maybe you can implement next year now that you know some of the ins and outs of the scoring or how things are developed, or just questions that you might have on content, pedagogy, or anything else in between there. So my name is Bryan Passwater. I am a teacher in Lebanon, Indiana at Lebanon High School. And I'm here with my co-host, Tony, and I will let him introduce himself.
Thank you, Brian. Hi, I'm Tony Record, and I am a teacher also in Indiana, just a few miles down the road from Brian at Avon High School.
Excellent. So we're going to jump right into this, and kind of the format is, for those of you who are on, and we have several of you that have joined us already, for those of you that are on here live with us, we're hoping that this is not just a sit and get, it's not just to listen to us discuss, but really it's an opportunity for you to have any of your questions, any of your burning questions answered. And like I said, it could be a scoring question about how the rubrics are made, or about how points are awarded, about why things are done the way they are. Anything that you feel like is going to be helpful or useful to you, or things that you just had to have those burning questions, like why has this problem been like this? My kids write things this way, but the rubrics look like this. Is that acceptable? Anything that you can imagine, you are more than welcome to ask here. There's a chat feature on your screen, and if you look at the chat box, you can type your question in there, and then we'll ask it to Steve. So please throw any questions that you have in there, and Steve will be happy to answer them to the best of his ability tonight. So Steve, I'm going to get us started off. I had a couple questions that were sent to me, and I'll start off with one of them. I know that Tony had a couple as well. So we'll start off with those while people are sending their own questions in. And so this is sort of a, I don't know what the word is, it's controversial or not, but with the new emphasis on communication, conditions of theorems and things like that on the exam, with the redesign after 2016, L'Hôpital's rule, right? And this has been kind of a lively discussion on the AP Calculus teacher Facebook page. And if you're on here tonight, or you're listening to the recording of this, and you're not a member of the AP Calculus Facebook page group, I would highly recommend that you jump on there and join as well, because it's a great way to get resources, answer questions, and get just good advice and share with other teachers. But one of the debates that's come up many, many times is, with the new redesign, we don't want students saying on the problem equals 0 over 0. Even if they continue that and do L'Hôpital's rule, that statement that a limit equals 0 over 0 is going to cause at least a deduction of a point for that linkage error, right? And some people have been questioning why it seems like it might be somewhat pedantic. It may be a little bit trite or nuanced that we're taking off a point for that. Can you kind of walk us through that about, where does the College Board draw the line on those kind of decisions? We let some things go, other things not. Walk us through on L'Hôpital's rule, the logic, and as a professor of mathematics, why you think it's important that nuance is not just a nuance, but it's an issue that needs to be addressed.
Well, I'll try to address this, Brian, from two different perspectives. Let's just think about this from the College Board's perspective, or from the grading perspective. So first of all, I was not involved in this decision to take away or not award points if a student wrote that a limit was equal to 0 over 0, okay? Somewhere, somehow, within the last couple of years, the decision was made that if a student writes that limit is equal to 0 over 0, that's not sufficient for saying that the conditions are met for L'Hôpital's rule. that expression 0 over 0 is not a valid mathematical expression.
Mhm.
Now, again, I don't know how that decision was made. Was certainly made by the scoring leadership under Stephen Davis. A little bit of behind the scenes, I can tell you that I have already had some discussions about this with the new chief reader coming in June, Julie Clark. And the reason is because here's my bias on this, Brian. I actually think that that's a valid way to express that limit. And my reasoning for that is that's a valid mathematical expression, and we all know, we understand what it means. And we have other mathematical expressions that we write that aren't really true either, but we know what they mean. And here's a perfect example, in my opinion. Suppose we have a limit and we write that it equals infinity.
Mhm.
Well, that's not correct. You can't have a limit equal to infinity, but we as mathematicians all know what that means. It describes a special kind of behavior of that function. And so my argument is, not the College Board, not the grading, but my argument is that if a student writes, if I write 0 over 0, you know exactly what that means. And in my mind, in my naive way of thinking about things, that's a signal that a student has to do something.
Sure.
Prior to L'Hopital's rule, a student might have to do some factoring. Prior to L'Hopital's rule, a student might have to divide numerator and denominator by a power of x. So I don't have a problem with 0 over 0. But somewhere in the last couple of years, the decision was made that they will not accept 0 over 0. And I'm going to say the reading leadership, decided that that is not good mathematical notation. Now, that may change. I doubt it's going to change this year, but that may change in the coming years. So if a student gets a L'Hopital problem, the bottom line is they should separately write the limit of the numerator is equal to 0, the limit of the denominator is equal to 0, and maybe something like, therefore, use L'Hopital, and then proceed to take the limit of the derivative of the top divided by the derivative of the bottom and go on from there. So I guess in summary, Brian, it was the decision made by the scoring leadership. I don't happen to agree with that, but I follow the party line here. We'll do it. We'll accept it. I don't think it's going to change for this year if there is a L'Hopital's problem on the free response questions. It's not that hard for students to do this, to split up and take a look at the top and take a look at the bottom separately. There's a good example from last year. Yep, very good. So here the student has taken a look in part D, has examined the limit as x goes to pi over 2 of the numerator. They've taken a look at the limit as x goes to pi over 2 of the denominator. Both of them are 0. Therefore, by L'Hopital's rule, we take the limit of that quotient is the limit as x goes to pi over 2 of f prime divided by g prime. So that's the way they want right now. That's the way that they would like students to solve these problems.
And
I'm sorry, Brian. I think that was a little long-winded, but
no, I think that was great. Because this actually has, as a College Board consultant, and I'm sure Tony hears the same thing. This is one of the things that really comes up quite a bit. And two things come up. One is they want to know why they have to do this. And then two, the other question that comes up a lot is not just, how do the kids get the point, but once the teachers know, there's a lot of those questions that you brought up, like, well, why is that the line or where that line is? So what I'm hearing you say is it doesn't necessarily, that there might be some division among math professors on where that line should be, but regardless of where we fall, this is how it's being scored for right now.
That is correct. Excellent summary, Brian. Yep, I agree with that. Yep. I don't think I'm the only one who thinks that about 0 over 0. So, yeah, I think there is some division, maybe isn't the best word, but yeah, there's some, we're talking about it. How about that? There's some discussion about this.
Sure, absolutely. Yeah, that was great. We have a question that was just sent in from Madison County, Indiana, and it says, if you're given the graph of a derivative in the problem stem, and the problem asks for where the original function has an inflection point, can you simply say there's an inflection point where the graph's derivative has a relative minimum or a maximum. So if you're given f prime, can you describe inflection points of f by saying that f prime has a relative extrema?
You can justify the inflection point if you use the graph of f prime that's given in the stem of the problem. So it's a little unclear to me whether this person is using the definition of the inflection point. It appears that they want to use the graph of the derivative, and that would be okay.
Sure. And I'm going to bring up an example. I'm going to try to, as people ask questions, I'm going to kind of hopefully bring up a question that I think is addressing what they're asking for.
Yep.
So this is from the 2017 exam, and they were given a graph of f prime. It didn't ask in this question for a point of inflection of f, but had it been, part C was a point of inflection, could they have said there's a point of inflection at x equals 3 because f prime has a relative maximum?
Yes. I think that's worth the point.
Absolutely. Perfect.
And in fact, I think, Brian, if you have a second, maybe you could look at the 2018 the exam from last year.
Yes, and
that had that controversial inflection point question, but
yes, and that was an interesting one, right?
Indeed.
Because I know that scoring that was a little bit of a challenge, right?
Yes, sir. Yeah.
This is the question right here from 2018.
Yeah. Yep.
And one quick correction, that question came from Madison Consolidated,
okay.
not Madison County. It's kind of funny. A friend of mine is who posted that question, and so I know I'm going to get grief about that the next time I see him. So I need to apologize to him about doing that. Yeah. So on a question like this, and it does ask, right, find the x coordinate of each point of inflection on the graph of f. Now, in this case, elaborate on this, because this is something that I think a lot of teachers, there's a lot of miscommunication, and there's a lot of confusion on a problem like this. And it's because it's asking about the graph of f in the problem, but we're not given a graph that's related to f. We're given a graph of g that we know is connected to f, but it's named differently. So what would a student have to say here when they're given a graph of g, which we know happens to be f prime, if we make that connection? But what are they going to have to say to get the point on f's point of inflection in a problem like this?
Well, I think if you look at the standard for this one, I believe it says something like there is a point of inflection at x equal 4 because the graph of g changes from decreasing to increasing at that point. And that would also allow the student to say, well, there's a relative minimum there. So take a quick look, if you can, at the scoring standard for that one.
Sure. So let me bring this scoring standard up from 2018. And it looks like now that they have changed, or they don't put the questions on the thing. So this is it, right? So on part D, it says the graph of f has an inflection point at x equals 4 because, but notice they have that connection between f prime and g. So if they didn't make that connection, if they didn't mention in the problem that f prime equals g, if they just said that g changes from decreasing to increasing, would that have earned the point, or are they going to have to connect them because they're named as different functions?
I think if I were scoring this one, Brian, I think I'd give it to them because I think in the statement of the problem it says that g is the derivative of f.
Gotcha.
Or f prime is g. So I don't think I would look for the connection right there, or require that the connection be stated. So that's pretty minimal.
Sure.
To get that point, and just saying the justification is that it changes from decreasing to increasing at x equal 4.
So because this particular problem in the stem, if I can bring it back, it says that g is the derivative of f. We didn't have to make the connection, but had it been a function defined by an integral, then would they have to have that little connection there, do you think?
Yes, sir, I do.
Okay, so
Good
we got a
question.
little fortunate here because it said explicitly that g is f prime in the stem.
Yep.
They didn't have to reconnect that. Perfect.
Yep, I agree.
Perfect.
I agree.
Tony's going to jump in here.
Okay.
Yes, yeah. I wanted to say, Lee, that was a great question. thank you from Madison Consolidated School. But Madison County is where I hear a lot of really nice bridges are located, if I remember correctly. But anyway, we have a question from Diane Wishmeyer. She wants to know about, in a free response question, if a student is asked to find an absolute maximum or an absolute minimum, is making a table by checking endpoints sufficient for the justification point? And I believe, yep, 2017 3C will address that, Bryan.
Yeah, absolutely, Diane. The justification point can be a table of values. A table of values containing the endpoints, the x values, the endpoints, and any place where the derivative is 0 or does not exist, and the value of the function. That's the justification. So if you present that table and then the student were to say, well, look, the absolute minimum, depending on what the question asks for, the absolute minimum occurs at x equals 2 and the absolute minimum value is negative 17, they get full credit. The justification is the table. Excellent question.
Yeah. And as a follow-up to that, Steve, if a student were to, let's say it was an absolute minimum problem, and in the table 12 was clearly the minimum value, and that's in the, let's say it's in the column where the dependent variable is. If a student just wrote the word minimum alongside that number, would that fly?
I'd have to say probably, but as you know, tough to say without actually seeing an example of that, Tony, but yeah, probably.
And so it might be a better practice for perhaps the student to write a small phrase and say the absolute minimum is, state that again.
Absolutely. Sorry. Yes. Yes.
And Steve, I'm going to put a follow-up on Tony's follow-up because my students will ask this question a lot, and I think I know the answer, but I want to get your opinion, and not everyone may have thought about this. On this particular problem that we're looking at on the screen, it's asking for the absolute minimum, and my students use the candidates test, and I have some students that will say, well, at -2, that's a relative maximum. So do I have to include that point in my table when I know that it's not possible? So do the students have to include that number? And if they don't, do they have to say why they're not including it?
Yeah, that's a good question. In general, they do not have to include that value in their table, but in general, they have to present a reason why it's excluded.
So if students know something, this is part of that communication issue, correct?
Is this part of the what, Bryan?
The communication.
Yeah, I think so. I think that's a good point. Yes.
Just to either put all the values in the table or state explicitly why it is they're not going to.
They're excluded. Yep.
Yeah.
Exactly.
Perfect. I think Tony has one more.
Yeah. This is a question that actually sort of surfaced among my students today, and several teachers here in Central Indiana posed this to me, but it's secret that the redesign from 2017 has sort of spawned an increased emphasis on assessing students' knowledge of the conditions that must be met before the application of a various theorem or a process or a rule. I want you to speak specifically about the idea of continuity. Under what circumstances do you feel that students should be very aware that it could be very vital to mention that a function is continuous before applying said application?
Well, certainly we just saw a good example of that with the L'Hopital rule theorem, didn't we? Mm-hmm. If you can sneak back to that for a second, Bryan.
Yeah. Let me go back to do you want me to go to the problem or the rubric here?
If you can go back to the rubric for just a second.
Sure.
I think that was 2018.
Yeah.
Yeah. So there, it was important that the student said that G is continuous. And the reason is because that's the only way that you can figure out that limit as x goes to pi over 2 of G of x. So if the function G is continuous, you can determine its limit by plugging in that x value. So that's certainly one place where it's important. I think stating continuity in some of the other named theorems is important, for example, intermediate value theorem. But I can't, off the top of my head, think of another place where it might be really important to state that. I can't think of a problem offhand. Can either of you two?
Some of the existence theorems, I think you mentioned intermediate value, and perhaps the mean value theorem would be another
yeah.
example.
Yeah.
And Stephen, on the mean value theorem, I'm going to pose a lot of questions to you that I think a lot of people may have heard and may already know the answer to, but I think there is a lot of, as we do workshop presentations, it's clear that a lot of teachers maybe not know some of these little nuances. And the mean value theorem requires that the function is continuous and differentiable. And a lot of teachers will say, well, why do they have to state that it's continuous when the STEM said it was differentiable? Differentiability means it has to be continuous. And it seems like with the redesign, pre-2017, we sort of let it slide that if a student said that the function was differentiable, that we knew they meant it was continuous. And it seems like after the redesign, we're looking more for that specific mentioning of continuity as well to use mean value theorem. Is that, do you agree with that? Do you disagree with that? And what might have been that shift?
I think that's an excellent point, Brian. I can't point to any one particular conversation or discussion that I was involved in where that issue specifically came up. But clearly there are instances now where the student is required to say something about continuity. The one you have on the screen right here is an excellent example. You're given that the function is differentiable, but the student had to say that it was continuous.
Sure.
So yes, I think it's part of something you said a while ago, and that's communication. I think we're looking for succinct communication from students now. And not unfortunately, but yeah, I think we're requiring them to say that.
And do you think we're just going to, on this next year's test, do you think we're just going to get a million kids that just start saying everything's continuous because they don't know exactly what that word means and how it's used?
Well, that's, we as teachers are master strategists, and, it's very easy for us to say, well, students, if you see the phrase function G is differentiable, there would be nothing wrong with a student stating that function G is continuous within their solution, because it may get points, it likely may not, but it's not incorrect mathematics.
Yeah. Oh, that's a good point, Tony. Yeah, that's a test-taking strategy. Yeah.
And I'm a little bit ashamed to say that I told my students, if you ever see a STEM that tells you that the function is differentiable, immediately just write down, therefore it's continuous. And I said, write that down because you never know when you might need it, but also it might make you start thinking about continuity, that that might be the strategy to solve a problem, right? The continuity part. But my kids are starting to get trained, and I've seen a lot of teachers now that I think it's interesting that the first year that L'Hôpital appeared on the AB operational FRQs was 2018, right? We didn't see one on the 2017 AB operational FRQs. And the first time they included it, they included this little other piece of continuity, which really was quite a wrinkle. Because I remember, I'm one of those people that as soon as the problems are released 48 hours after the exam, I type up my solutions as quickly as possible and I send them out. And I remember I sent them out to a couple people. And I think it was Mark Corrali that sent mine back and said, you did a nice job. You got an 8 out of 9 on this problem. And I felt a little bit incredulous until I realized that's a really nuanced point. They really came out, the College Board came out swinging, I think, with their first L'Hôpital's application.
Yeah, excellent point.
So, Aaron asks, Steve, we're going to kind of shift it away for a moment from a specific problem, but just some advice. So he wants to know, what's the best piece of advice that you have to give a veteran teacher, so not a new teacher, but a veteran teacher, with the relatively new focus on these impacts? So, how do these impacts affect a teacher who's been teaching for a long time?
Well, I would focus, my focus would be on I think the last two impacts, which are communication and notational fluency. I would suggest that your students, number one, when they're looking at the free response questions, I know it's silly, but make sure that they answer the question and make sure they do it as short or as succinctly as possible. Oftentimes, it's not meant to be misleading, but oftentimes there's an awful lot of extra room given in those free response booklets. Mm-hmm. Answer the question and answer it as short or as succinctly as possible. I think that's important. And the second thing is, I believe that we have a wonderful language here. Mathematical notation, I think, is so beautiful and elegant. And I'm getting the sign charts at some point on this, Brian. But I really think that students should use proper mathematical notation. And in doing so, that will help them convey their solutions in a very succinct manner. So I would focus on communication. I'd focus on using proper notation. Answer the question, and you'll get all fives. How about that?
That'd be wonderful. So Steve, I know that you work with a lot of high school teachers and you do a great job with them, but your day job, so to speak, is at the college level. How does a high school teacher, you said, focus a lot on communication? Can you give any ideas or examples of, like, on a day-to-day basis, what does that look like? How do you tangibly focus on the communication part in your classroom?
In my classroom, I think of communication as presenting a logical argument, presenting a solution in a logical way that I can read through it, I can see what you did. It doesn't necessarily have to include a lot of words, Brian, but I'm looking for solution strategies that are logical and easy to follow and use proper mathematical notation. That's what I look for in my classes.
Gotcha. Excellent.
We've got a couple of more questions in the chat here.
Okay, shoot.
This may have been somewhat addressed. Asked a really good question about are points or the awarded when the scoring guidelines for a part are satisfied, but the students may provide maybe an extra relative extrema or an extra point of inflection. Maybe they lie outside of a given interval. It asks, would credit still be awarded? Tough one.
Well, that's a tough one, again, to answer without a specific example, but I would say in general, if the solution is incorrect, they will not receive full credit. So as a more specific example, if let's say there are two inflection points, two values of x at which a graph of a function has an inflection point, and a student reports 3, well, they're not going to get full credit. Will they get partial credit? Absolutely. I mean, in general, that sort of a question would not be worth just a single point, so they're probably going to get partial credit in some way. But if
I think along this, go ahead.
I was just going to say, if the answer is wrong, in general, they're not going to get full credit.
Okay. Now, what if the answer, it may not necessarily be wrong, but it's heavily assumed? Does that fall under the same category? It may or may not be, but the student specifically stated that it was.
I tried that again, Tony. What do you mean?
Well, let's say that they make a statement about a point of inflection that exists, but given the information in the problem, it's impossible to tell whether it is or not. So it's not necessarily wrong, but it may not be correct after all. Does that make sense? So they're assuming the existence of a point of inflection.
So if suppose there's only one point of inflection at x equal 4, and the student says, okay, well, I think there are 2 points of inflection at x equal 3 and x equal 4, but I can't tell you why. I have no justification. So I'm going to go way out on a limb here. Let's suppose that's a 2-point question. 1 point for the x value and 1 point for the justification. I would say it is possible that the student would get 1 point partial credit for reporting the x equal 4, but certainly not the justification, because you can't justify a wrong answer.
There you go.
And I think, 2 follow-ups, Steve, to this. One, I'm sure I know the answer to, but another one, I brought this graph up of 2013, and it's actually a great question because this came up exactly in my class today. We did a little FRQ practice, and part A asked for the student to find the local minimum of f, and we know that there's only a local minimum at x equals 6 here on the screen.
Yes.
But one of my students had just written extra information. They said there's a local minimum at x equals 6 because f prime changes sign from negative to positive. All that was great. But they also said there's a relative maximum at x equals 4, and they gave a reason for it. So again, it was correct, but it had nothing to do with the question. So is that going to be ignored since they did answer the question and there was nothing false on the page?
Yeah, that's sort of a different question in my mind, Brian, and that's a really good question. If a student gives you extra information that is correct, well, certainly that's okay. If a student gives you extra information that's wrong, well, that changes from question to question, as you guys probably know. Sometimes we just ignore that extra information. Sometimes we don't. Sometimes a student will just write a lot of extra information that, darn it, is wrong, and they may lose a point.
Sure. Yeah, absolutely.
And, I don't think there's a general answer to that. I mean, it's very dependent upon who the chief reader is. It's dependent upon the question.
And what if, like, this comes up and it seems like one year this happened one way, another year it was scored a different way, and it was a question specifically asked the students to write the slope. This is actually a good example on part D. It said, find the slope of the line tangent. It's asking for a very specific piece, and the students went ahead and wrote the entire tangent line. I thought I remembered, in the past, generally, as long as that tangent line was correct and the slope was clearly labeled, they were fine. But I thought I remembered recently there was a year that if they did go too far, they said, since we've asked them specifically for the slope, if they gave us the line, we're going to assume they didn't understand the question and they didn't get full points. Am I off base on that, or is that something that might have happened?
No, there was something about this last year, and I'd have to go back and look to be exactly sure how that was scored. But in general, if they find the correct slope, but they report that slope in a correct tangent line, then I believe they would get the point. Now, again, that was just one example, 1 year. Mm-hmm. If they do not label the slope in any way and it's reported in an incorrect tangent line, well, then, that's a gray area. Does the student really know what's going on? And so you can see where that might be marked incorrect. So I don't think there's a general way to answer that one either. I mean, this is an excellent example. We can loop back to something we were talking about 15, 20 minutes ago, and that is, darn it, answer the question.
Sure.
If it asks for the slope of the line tangent, report the slope.
Yep. In my classroom, I write really big, RTQ, ATQ. Read the question, answer the question, right?
Yeah.
Make sure you stay on topic. And one more thing on this graph before Tony jumps into it. There's a couple more questions here in the queue I want him to get to, but on a problem like this, my kids ask me this all the time. On part C, it says, when is the graph of F both concave down and increasing? And since we're given a graph of F prime, we're looking to see when this graph is above the x-axis, but with a negative slope. And we see here in the beginning from 0 to 1, that interval would definitely fit the bill, right? That would be part of our solution. But what happens when you have a closed interval from 0 to 1, and kids might do it on either end? They might say negative infinity to 1, or on the other end, if there's something supposed to end at 8 on the screen, they went from 6 to infinity because they weren't really thinking about the fact that this graph is stopping. There's no arrows. How are those, those extensions? This kind of ties back to Tony's question, where it's like, it's not true, but we don't know if it's false. It's one of those gray areas. How are those decisions made on these kind of questions?
And I think, Brian, that's made year to year, question to question, who the chief reader is, who the question leader is. Certainly in my class, that's wrong.
Sure.
But I think we all understand that under the pressure of a high-stakes exam, we might let something like that go. But again, it's very year and question dependent.
And so would you recommend, just as not as the end all be all, but as a classroom teacher during the year, maybe penalize that kid on that just so they feel the sting of losing that point in class? So that way they're not in that gray area of hoping that maybe it's not deducted on the actual exam?
Absolutely, Brian. Absolutely.
Awesome. Tony, go ahead.
All right, sounds good. We've got a question.
I thought you were going to ask about endpoints there, but we'll let that sit. Okay?
The parentha bracket. The parentha bracket. There we go.
That'll be our 3-hour follow-up.
Good. Okay. Good.
Open and closed intervals.
Okay.
Yeah. And X's really do look like T's. tilt
Yes,
your
they
head.
do. They do. They do indeed.
Kay asks, given a table problem where you're given values of velocity and time, if you are asked how many times the acceleration is equal to 0, what is the best way to justify that?
Ooh, let's see. Do we have an example of that anywhere, Brian, that you can think of? Any question that we could bring up like that?
We do.
I've been searching.
It does. Let me think for a moment. I'll let you kind of wax poetically about the general idea. We had one just recently. It may have been 2015. It may not have asked this question, but there was a velocity table, I believe, and it had the negative 220 as one of the terms. Let me see if I'm correct. There we go. How about that?
Oh, very good. Very good.
This one, you can see we do a lot of FRQs, right?
Okay.
But this one, it didn't ask this question, and it's a little bit more trivial. I think on the actual exam, there was a question that asked this exact thing. And rather than trying to find that question, on a question like this, obviously it starts with 0. So this is kind of a moot point, from the beginning here. But if this had asked what Tony had asked, how many times does the acceleration equal 0? What's the best way? Because I think it's very intuitively obvious for most students, but it's very challenging for them to put that intuitiveness into words.
Boy, I'm not sure what I would be looking for there. I mean, if the table is the only thing given, then theoretically you'd have to justify your answer by looking at that table. So let's see, I guess, could I apply the mean value theorem on this function in 2 places? I suppose that would be justification.
Would you have to tie that to the IVT following that then?
Hey, Brian, I think it's on one of the papers that you had in your webinar, maybe the problem that you wrote on the table problems.
Oh, okay. Yeah, so I'll let Steve continue here. And Steve, while you're looking at this, I'm going to try to bring up another question here.
Well, I don't think I'm going to go to the intermediate value theorem here. I mean, that would be for values of the velocity. Didn't you ask me about the value of the acceleration here?
Yeah, but what I was saying was if we do the MVT, between 20 and 24, we can only guarantee that the acceleration must be negative somewhere, right?
Yeah, right.
And then from 24 to 40, we can guarantee it must be positive somewhere. So then wouldn't we do the IVT to guarantee that it actually equals 0 somewhere between there as well?
Gotcha. And you know what, Brian? I can't imagine a free response question expecting students to do that. And if you remember correctly, there was a question on last year's exam in which some students tried to solve a problem by 2 applications of the mean value theorem and then the IVT, just as you described. But that was really the long-winded way to do that and very difficult to show because of all the assumptions and all the things you had to make sure that were true. I just can't imagine something like that. But okay, if it were asked, yes, I think you'd have to do that.
And this is one of the questions that I was inspired from an AP problem here. So this is not an actual AP release question, but it gave them the velocity here. And this question, it wasn't how many times must the velocity or must the acceleration equal 0, but it was how many times must the velocity equal 0.
Okay.
So more of an IVT approach.
Correct.
But there's a lot of word. You can imagine trying to do IVT on this. What kind of phrasing or wording do you think we'd want to see from a student?
Well, I think we'd want to see an inequality here. We'd want to see something like, if I've got this correct here, V of 1 is less than or equal to 0 is less than or equal to V of 3. And so if the conditions of the intermediate value theorem are met, there must be a value t somewhere between 1 and 3 where the velocity is 0. And then similarly, let's see, we have the velocity equal to 0 at 7, correct?
Yes.
All right, and then I guess we'd have to apply the intermediate value theorem once again between 8 and 10.
Sure. And
So I think I'd be looking for an inequality, and then because the conditions of the theorem are met, there must be some value of t where the velocity is 0 in this interval.
I want to drill down a little bit on what you said, Steve, because the first interval between 1 and 3 made perfect sense. For the 8 to 10, are we expecting the students to repeat that entire process, or could they just say something along the lines of, similarly, there must be a time between 8 and 10 where V of t equals 0?
I wouldn't go with similarly, Brian. I think I'd show the interval once again.
Okay. So you're taking kind of the Mark Corrali approach of, it's a one-time test for all the credit. Don't cut things short.
Don't cut corners. Absolutely.
Don't cut corners.
Absolutely.
I appreciate that. Another question here from Teresa. So Teresa says, when it comes to series questions, so we're going to move to the BC side for a moment.
Okay.
And writing a general term. What if the student writes an expression that generates terms starting at 0, but there's also a way to write a general term that that generates the correct term starting at n equals 1? So I'm not sure if that was clear, but a lot of times, the general term, if you technically plugged in the bottom number, it may give you a different value. Do they need to worry about whether it's generated at 1 or 0, or are both going to be acceptable?
That's an excellent question, and the short answer is it doesn't matter where it starts, so long as the general term is correct. So readers are trained to recognize the general term for n starting at 0 or 1, maybe even 2. So that's fine.
Okay, perfect. So the general term is pretty ambiguous. It doesn't have to be. It's basically something that would generate, if you put all the n values in that, you would get all the terms eventually.
Yes, sir.
Okay, perfect. Real quick on this series question, Steve, I'm just curious on your advice, because obviously for the BC teachers out here, the thing that seems always to be the most difficult is series, right?
Yeah.
Is there a strategy that, a lot of the textbooks have sort of the plan that you start with convergence tests, and then you move into, Taylor series and Taylor polynomials. And then there's some textbooks, I think, that might reverse it a little bit. They might start with polynomials and series to give rise to the need of convergence to lead into some of those convergence tests. Have you found a way that you feel like is the most logical? How does your textbook, handle that kind of stuff?
Well, I handle that in the first method, the first sequencing you talked about, Brian, and the reason is because for me, I just think that's the easier way to do it. I think jumping right into Taylor polynomials and representing a function with a polynomial, to me, that's just a very difficult topic. I mean, it just doesn't seem like it can be done. And I think, in my opinion, I think students need a lot of practice with series notation, and they have to have those convergence theorems down cold before you get to Taylor series and Taylor polynomials. So I feel that the first method you described is better. I understand the second method. I get it. I think, in my mind, the better students really can do that, can absorb that, can understand that better. But I prefer the first sequence.
Perfect. Thank you.
All right. We've got a question here from Raul from Texas concerning differential equations, which we haven't talked about this afternoon. He wants to know, on a free response question, if you have a differential equation that's your standard dy over dx is equal to k times y, so the rate of change is proportional to the amount, can a student recognize that and automatically go right to y equals ce raised to the kt, or kect, as we affectionately call it in a lot of classrooms across America?
Okay, two answers to that one, Tony. First of all, I think I've seen a couple of these differential equations given on the multiple choice exam, and on those, multiple choice portion, excuse me. And I think, of course, on those problems, the students would be expected to know that right away. Now, on a free response question, I don't think you're going to see that differential equation where the student is asked to solve that differential equation. If they were asked to solve that, then they'd have to solve it by, well, separating the variables and showing all of the steps. So I think the bottom line is you're not going to see a question where a student is asked to solve that. Is this a good differential equation to have in your back pocket to use in some way? Absolutely. Okay, that it's good that a student knows that's the solution. But let's go back to something you talked about a couple of minutes ago. Don't take any shortcuts. Did I lose you guys?
I'm here.
Okay.
Oh, we're still we're just taking that in. I like that. I like that. We're playing with you.
Okay.
No, that's a great answer. That's yeah.
Steve, I want to bring up a question here. I'm hoping I can find it. For those of you who are logged in and maybe you were not here in the very beginning, we're doing an open Q&A with former chief reader Steve Kokoska. Steve Kokoska has been pivotal in the AP reading for many years. And in his most recent position before his current one was the chief reader. And he is the author of a great textbook, the Stuart Kokoska calculus textbook. I highly recommend that you take a look at it. And he's been heavily involved with the College Board and College Board Consulting, and he's been very gracious enough to answer any questions that you have here tonight. So if you have any questions or things that have been kind of burning, wanting to know, this is the perfect time to ask. So feel free to type into the chat feature there any questions that you might have for Steve. Steve, I'm going to take us to a follow-up to the free response questions that Tony was talking about, and it's the 2011 landfill question. I think it's kind of infamous for me, because I tell my students it went so poorly for students that they asked essentially the exact same question the next year.
Yeah.
In terms of a baby bird,
Yes.
almost identical. But one of the things that always kind of bugged me on this problem, and it actually confused my students, and it was almost like my students who were thinkers, my thinking students got tripped up on this, because they kept trying to imagine this scenario, and they kept saying to me, why in the world would the rate of waste be growing depending on the amount of waste in this problem? And that just flummoxed them. Do you guys see that a lot, where you have students that almost get tripped up because they think too much into a question, especially when it's contextual, instead of just doing the math? And what are some strategies that you've seen or heard that might help students get away from getting too caught up in the context and seeing the problem for what it is?
Yeah, it's a great question, Brian. And I would recommend for students not to worry about, the real practical implications of the problem. Solve the problem as it's given. But I will tell you, I'll temper that a little bit. Having been on the development committee, I want you to know that we really do think about these questions from a practical standpoint. Making sure that, for example, the water flowing through a pipe is reasonable, making sure that, the gravel accumulating here in a pile is reasonable. So there's a lot of discussion about that. There was a question a while ago about a plane taking off and its velocity and acceleration. Mm-hmm. And, I remember vividly discussions about that, making sure that it was realistic. So I wouldn't worry too much about the practical nature of the problem. We do think about that. Just look at the mathematics, and although it may not seem reasonable, solve the mathematics as it's given.
Sure.
And Brian, you bring up another good question too, and I want to make sure that everybody listening understands this too. There's a lot of discussion about these contextual problems, and there's a lot on the development committee, a lot of discussion on the development committee to make sure that the wording is, as short as possible, and they certainly don't try to make these questions misleading in any way. There are issues, of course, with students where English is a second language. And we care deeply about that and think very carefully about that, because we certainly don't want to confuse anyone.
Sure. So with that said, let's talk about the plankton problem for once.
Do we have to?
My BC kids really had a tough time with this. And there was a little bit of discussion on the Facebook group about this question this spring, because a lot of teachers thought it might have given some of the science students some advantages or English as second language students as a disadvantage. And I'm really glad to hear what you had said, about the development committee. And I know that the ETS and College Board have a pretty intense bias check, right? To check for bias in questions.
Yeah, they do. Yeah.
And they've thrown questions out or had them reworded to avoid those kind of things. This question didn't do particularly well, but did you feel like this was a kind of a heavy science context that maybe some students might have disadvantage of, or do you feel like that still fits in that same category?
No, you're absolutely right. This was a tough question. There's a lot of words here. Thankfully, I was not on the development committee when this question was written, so I'm not going to take any blame for this one. If I remember correctly, Brian, maybe you can check this for me quickly, but if I remember correctly, the scoring standard for this was very short. If you understood what was going on here, it was pretty easy to get all the points, wasn't it?
Yes.
Yeah, look at what was going on here in A and B. Yes, set up the integral. In part A, let's see, all right, they had to have the meaning with the units, but in part B, all they had to write really was that integral, that definite integral, and the answer. They really didn't need that sentence.
Sure.
C was a little longer. What was D? Can you arrow down just a little bit for D?
That was a parametric problem.
Yeah, that wasn't bad either. So I don't know. I guess I see if there's a pattern here. Often in these questions where there's a lot of words, they can be solved very quickly.
Sure. Yeah, and I was telling my students that you never want to check out of a problem early because there's a lot of things that are pretty straightforward on this. Part A, obviously, the taking of the derivative with the calculator is clearly got to be the simplest part of this problem. Part D, most BC students, their favorite and strongest topic is parametrics because it's learning a few formulas and just typing them into your calculator for the most part.
Yes.
There were two quite simple points here in part D that a lot of students, I think, had given up on after reading B or C and then didn't realize that there was an easier question earlier on in the problem there.
Yeah, I agree. It
wasn't that difficult at all to solve there. But I know that a lot of students had a hard time. And, just out of curiosity, on part A, once the units, in what does a meter to the fourth power look like, Steve?
I'm not sure I can answer that one, Brian.
This is maybe another reason why, a lot of mathematicians and science people don't like that meter squared or second squared notation because it doesn't always mean what you think it means. I always ask my students, what's a square second? When they say it's meters per second squared, I tell them just meters per second, it at least gives you some context of envisioning what's going on there. So
yeah, good point.
Absolutely. So, Steve, the exam is on Tuesday. So teachers who are listening to this tonight or even, maybe tomorrow morning when we were able to post it, they're going to have at most 2 days of classroom instruction and maybe a couple days that their kids are doing practice problems at home. If you were a teacher and you had a kid who was kind of on that border, the high 2, they had a chance to get a 3, but you're thinking, man, we're short on time. I want you to practice, 1 or 2 topics, right? If you try to throw everything at a kid at the end, none of it sticks, right? If a kid was going to be doing several FRQs or several practice problems, what might be a topic that you think would be worth investing their time on during the short amount of time that you feel like is going to have good rewards, but also it's something that's going to be attainable that they could actually improve on and do fairly well if that question comes up?
I guess I would recommend 2 types of problems. I'd recommend an area volume problem. We haven't really talked about any of those tonight, but I think if you would look at the free response questions, there's been an area volume type question, almost every single year. So I'd make sure you can do those. And I'd also make sure that you can do the functional analysis type problems. We've looked at a couple of those tonight.
Mm-hmm.
We are given the graph of F prime, for example, and you have to find places where there's a relative max or absolute max, absolute min, points of inflection. Where is the graph of F both increasing and concave up? I think the functional analysis, the area of volume problems are excellent ones to work on. If you've got a borderline student and they can knock those two off, I think they're in good shape.
Perfect. Could you also tell us in terms of the scoring, we've looked at these rubrics here, these scoring guidelines. Can you share with us a little bit, because you mentioned your time on the development committee, where do these questions come from? Who's writing these FRQs? And then where do the scoring guidelines come from? And does that change at the reading, right? So are these guidelines made in advance? Are the scoring guidelines made at the reading? And then how do you ensure, right? Because a lot of teachers, I'm sure you're aware of, will try to play the odds game to say, there hasn't been a parametric, FRQ the last couple of years, so there's got to be one this year. Or last year was a polar, so it won't be this year, right? And if there's not a polar FRQ, does that mean that we are pretty confident there's going to be multiple choice questions to balance that out, or how does that work?
Yeah, I think I believe what ETS does is, of course, with the curriculum framework now, they have a checklist, probably a spreadsheet somewhere. And of course, they want to make sure that every single topic is tested in some way on the exam, whether it's on the free response or the multiple choice part. So I don't think they purposely leave anything out. They look to make sure they cover every single topic, and a couple of topics more than once. Okay. How's the question developed? Well, look, the questions are written by members of the development committee. There's often they used to have, I don't know if they still do, but at least in my time on the development committee, we had a question bank. Mm-hmm. This was a notebook of about, I'm going to say 200 or so potential free response questions. These were questions written by people hired by ETS, AP Calculus teachers like yourself. And we would take those questions, for example, and try to mold it into a free response question. Often development committee members are given homework and said, well, look, we need a functional analysis type question on this exam, so you're going to have to write that one. The free response questions usually start out with multiple parts worth many more than 9 points. They might have, 8 to 10 parts. Mm-hmm. And then in discussion of the development committee, it gets whittled down to, usually 3 or 4 parts and, of course, 9 points. It's a long process. It usually takes 1.5 years to 2 years for a question from inception to exam. But they're all written by the development committee. They're all discussed by the development committee. And the chief reader generally writes a scoring standard for every single question as it's written. At least that's the way I did it. So if an individual on a committee wrote a question that had, 8 or 10 parts, I would write the scoring standard for each one of those parts. This is how I would score it. Then when we finally decide on the question, I would write a draft scoring standard. It'd be discussed at the development committee, make sure that the distribution of points was proper, was reasonable. And at least when I was doing it, we would go to the reading with that draft standard. And there would be discussions 3 to 5 days before the actual reading, and that standard could get molded a little bit, changed a little bit. Now things have changed a little bit from that sequence of events, from that scenario. Now, because there are so many exam forms, most of the scoring standards are actually pretty well set before you get to the reading. So there's still some discussion. There's still some changes in wording on the scoring standard, but in general, there isn't as much flexibility on site as there was, let's say, 3 or 4 years ago.
Excellent. I had a question that was sent to me, and I hope I am interpreting this question correctly. I think it's asking, as a chief reader and as someone who's been involved in calculus for a long time, this is more for next year, I think. If a teacher is teaching the year, is it better, or would you recommend that they cover all the topics and get through everything? Or if their students are struggling or they're behind, is it better to leave out some small topics and go deeper on some more essential understandings?
Boy, that's a tough one. If I were in that situation personally, Brian, I think I would skip some topics I don't think I try to cover everything in a cursory manner. I think I try to make sure that my students understand some subset of all the topics really well.
Sure. Do you, I know it's very different on the college side than the high school side. So some teachers will finish their curriculum a week before the AP exam or a couple days before, and then do a lot of, FRQs and AP style rigorous questions along the way. And then some teachers will zoom through and finish 5 or 6 weeks early and just spend 4 to 5 or 6 weeks reviewing and doing a lot of AP prep. Do you think both of those are valid strategies, or do you feel from the grading and your experiences that one of them is going to prove students better, not just in the AP exams, but in college better than the other one?
I don't think I can answer that one, Brian. I see advantages, disadvantages to both of them. What do you and Tony do?
I'll let Tony speak for himself, but honestly, for me, it's year to year. And I think it depends on my group of students. I try to have about 4 weeks at the end for review. That's kind of my goal. In the high school level, we have spring break, typically the first week of April in the Midwest. So we come back, April 7th, April 8th. It gives us about 4 weeks before the AP exam to do some review. Because I know that a lot of my students, they struggle, especially with limits at the beginning of the year. Just the conceptualness of that and the notation of that, and just all those ideas are just thrown right into it. So I feel like when you go back at the end of the year after seeing how derivatives work and how you introduce integration, it starts to make that sense of a limit make much more sense, right?
Okay.
So for me, it really depends on my group. I've had some years where I've only had 2 weeks before the exam, but we just did so much during the year. We weren't behind. We just did a lot of good FRQ practice. And so we kept spiraling those old topics in throughout the year. And so by the end of the year, we didn't need 4 weeks. We have been doing this the whole year. So it was more of just continuation. Tony, what do you guys do over at Avon?
It is a year to year. It's funny how you would think, I've now in my 30th year of teaching that I would have it locked in. And, about 20 years ago, I had made the commitment to give my students not only a great advanced placement calculus experience, but I wanted it to be a great Calculus 1 experience, because we know that there are topics that aren't necessarily tested on the advanced placement exam that are certainly a part of the Calc 1 curriculum. And the same thing can be said about BC material with the Calc 2. And so years ago, I could spend a fair amount of time on delta epsilon. I could spend a fair amount of time talking about the limit process for area, and I could do shell method and Simpson's rule even. But I found out that I have a lot harder time doing these things because I think students change. I've talked to a lot of teachers, and there's so many more distractions. And I think a lot of our teachers that might be in the chat that have been teaching for, let's say, N years, where N is greater than 15 or 20, might agree with that very notion. It's more difficult. I think I work harder now than I ever have as a teacher because of having to combat those. So we're always having to strategize, and we're always having to decide what to cut and what not to cut. And I think that's where just really having a very strong knowledge of what's in the curriculum framework is vital. And if you have questions, by golly, you do things like this. You come to a webinar like this, or you go to an APSI, or you establish relationships with somebody, even if they're 12 states away, that you know that you can trust, and you send emails, and you text, and you become friends, and you can gain knowledge that way. But you're right. Brian and I are very similar in that we're always having to change things. He and I have just decided that we're going to get together here in a few weeks, and we're going to talk about our school year next year and revamping things and putting things in different orders and whatnot. So it's evolving.
Yeah. Well, I'll just add one thing to that. I believe very strongly in the idea that students should be able to put everything together, this cumulative knowledge, not just being able to do well on Unit 1 or Unit 3. That's why I think that a final exam that is cumulative is extremely important. And that, in some sense, is what AP Calculus is all about, being able to put all of this material together. I mean, that's what a free response question is like. Lots of different ideas that you might not think are connected, but they are in some way. So this cumulative knowledge, I think, is very important.
Absolutely. Steve, we have taken up over an hour of your time. I want to thank everyone who has joined us tonight, and to all those who are going to download this and watch it later. I hope that you found this useful. I hope that you found it insightful. And I hope that those who are listening, maybe shoot. Steve would never in a million years want this, but if you have Steve, tell him thank you, because Steve has been a proponent and an advocate for teachers and students for a long time in the AP Calculus world. And on his complete own, was willing to do this for teachers. So I am indebted to you, Steve. And
No sweat.
I appreciate.
If you get any last minute questions here, Bryan, between now and the exam, forward them.
Yes. I will, absolutely. So I will definitely do that. So I am always grateful for your willingness to do those things with us. So for those of you who have joined on, again, thank you again. If you have any more questions, feel free to email me, and I'll have no problem bugging Steve.
Absolutely, that'd be great.
It's wonderful. And for all of you that are here, by the way, check out our calculus podcast. Tony and I have a calculus podcast. It doesn't get more nerdy than that. It's called CalcCast, CalcCast. And our guest last month was none other than Stephen Kokoska. And if you are going to be at the reading this summer, if you watch the podcast and you go and talk with Steve, he will have a little surprise for you. So check out that podcast for some more calculus talks and some more fun with former chief reader Steve Kokoska. So thank you guys so much.
Thank you, Bryan.
Steve, I look forward
to Tony.
And seeing you this summer.
Great work. Thank you, guys.
Thanks, Steve.
Thank you.
So long, everybody.
Have a great night.